Hi guys, so today we're going to talk about part two of the scientific investigation lab. So to start out, we have our aim, which is how can we use scientific method to investigate and solve a problem about crickets and the rate in which they chirp. So our do now for today is why is it important to conduct trials at least 3 times in an experiment? So take a moment to think about your answer and pause here, and then we'll get back to reviewing the answer in just a moment. All right, so why is it important to conduct trials at least 3 times? Well, we know that in order for an experiment to be accurate, you must repeat the process at least 3 times to collect data and see if it's accurate. So, in order for us to make sure our experiment on the cricket is accurate, we have to do the trials at least 3 times. In this experiment, we did collect data more than 3 times, so we are good to go, and our data is considered to be valid for a valid experiment. So, if we take a look at our data, this is what we have. Um, this is the findings that we found. So, just move this stuff out of the way. Okay, so what we have here is the effect of air temperature on cricket chirp rates. So as the air temperature increases and goes up, the chirp rate also increases. If we looked at the wind speed data, we see as the wind speed increases, the chirp rate remains the same. For atmospheric pressure, as the pressure increases, the chirp rates remain the same. As the number of crickets increases, the chirp rate remains the same. And as the humidity increases, the chirp rate remains the same. So from this data, we know that the only factor that is going to influence the rate in which a cricket chirps is air temperature. So let's take a look at the experiment and at the assignment on Schoology to see our next steps. So what you're going to do is you're going to take this data, right? So most of us did air temperature. If you did another independent variable, you're going to graph whatever data you collected. So you can use the data tables here, or you can use your own data that you collected on Tuesday and Wednesday. So what you're going to do is you're going to answer question number 1. So what kind of graph should the results from your data table use? So we want to show a change over time. And so we are going to use a line graph. Which axis does the independent variable belong on? So the independent, remember, is what you change. Is that going to go on the X or the Y axis? The X. So the X is on the bottom, and the Y-axis is going to have the number of chirps, which brings us to question number 3. What is the dependent variable in all experiments? So what did we measure for each of these different changing variables? The one thing that all of these graphs have in common is the chirp rate. That's what we were measuring. So that is our dependent variable. So here you are going to create a graph, a line graph, using the data that you have collected. So you can either create it on a Word document, you can create it on a piece of paper, and you can take a picture of it, whatever is the easiest method for you, and then you can attach it to your assignment or email it to me. Make sure that your graph has a title. Make sure that it has both labeled axes. So on the bottom, you'll have your independent variable. On the side, you will have your dependent variable. And you must have even scales. So what I mean by that is you cannot go from 0 to 2 to 8 to 12. You have to increase by an even scale. So you can go 0, 2, 4, 6. You can go 0, 5, 10, 15, 20. Whatever numbers are going to work for your data, but you cannot just skip around. So make sure that you have an even scale on your graph. Once you've graphed your data, you can continue on the scientific method lab to find out your conclusion. So if we go back to the lab and we draw our conclusion, there are a few questions for us to answer. So let's see if you have performed sufficient experiments to draw an accurate conclusion about the cause of chirping rates in crickets. To test your understanding of the problem, try answering a few questions. Which of the following factors determines the chirping rate in crickets? So we said the only thing on our data tables that changes the chirp rate is air temperature. So let's select air temperature. If you increase the air temperature, the chirp rate will. So if we increase air temp, what happens to the chirp rate? It also increases. If you double the air temperature, the chirp rate will. So here we have 5 degrees Celsius, and we had 4 chirps per minute. When we double it to 10 degrees Celsius, does 4 double to 40? No, if it doubled, it would go to 8. So it doesn't double, it doesn't cut itself in half or remain the same, so it's none of these. Assume that the cricket is chirping at a rate of 148 chirps per minute and slows to a rate of 10 chirps per minute. Could this change in behavior be explained by either an increase in temperature or a drop in wind speed? So we know that the increase in temperature is going to cause chirps to increase, so it's not going to slow it. And wind speed, we know from our data, has no effect. So the answer here would be no. Could this change in behavior be explained by both the air pressure and the humidity increasing? So same thing, we know that the air pressure and the humidity, regardless of the value, the chirps remain the same. So we can put no here. Could a drop in the number of crickets nearby and an increase in humidity have caused this change in behavior? So again, the number of crickets has no effect on the chirps. Same thing with the humidity. So again, we can say confidently that no, this will not cause a change. Congratulations, you have arrived at the most appropriate conclusion for this experiment. Great job, guys. It is temperature that affects the chirping rate of crickets. So what you're gonna do here is you're going to go back to your Schoology and you're going to write your conclusion. So discuss the results of your experiment, including does your data support your hypothesis? So if you think back to Tuesday and Wednesday, our hypothesis was about air temperature. Our hypothesis said if air temperature, so our hypothesis said this, right? If air temperature increases, then the chirp rate would decrease because crickets save their energy and chirp less when it is warmer, right? So our hypothesis was something similar to that. Based on our data, we now know that this is not true. So in our case, the data does not support our hypothesis. So our conclusion would be something like, the data does not support our hypothesis. We know this because, and then we're going to talk about our data. So you might say something like, we know this because as the air temperature increased, so did the chirps. At 5 degrees Celsius, we had 4 chirps per minute, and as it increased at 15 degrees Celsius, it increased to 76 chirps per minute. At the highest temperature, 45 degrees Celsius, we had the highest chirp rate at 292 chirps per minute. So you're going to put all of this information into your conclusion. What might be some sources of error and any suggestions for improvements to the experimental design? So how might there have been an error? Maybe a computer glitch. Maybe you put in the wrong values for the temperatures. Maybe you recorded data incorrectly. Tell me any mistakes that you may have made, and how could you improve the experimental design? So how can you alter this experiment to make it better? Once you have all of those questions answered and your graph complete, you can submit the second portion of your lab to be graded.